Well, hello everyone, and welcome back to Perceive 2021. Please give a warm welcome to a couple distinguished guests, Antoine Valverde, who is the lead data scientist at Letgo, and Julianne Mainet, who is the head of data science at Letgo. And we're going to be listening to an interesting presentation about AI applications in the secondhand markets. And gentlemen, welcome to our stage.
Yeah, so hello everybody. Thanks for the invitation. So I'm Antoine, and with Julianne, we're going to present to you two use cases of AI application in the second marketplace, and especially at Letgo. So just some brief words about Letgo. So Letgo has been founded in 2015. The main market is Turkey. It's on its base. Letgo is a marketplace for general goods ranging from electronics to fashion, sports, home and garden. And now we are focusing on transaction business, more especially with cars and also with goods and pay achievement. So Letgo is really a two-side marketplace. So we have sellers that want to sell a new stuff, and we have buyers willing to acquire new things at a second-hand cost. So if we want to have an overview of what this type of user expect from a marketplace platform, we can say that for the lister, they want to sell fast and at the right price. They also want to have a simple platform, frictionless workflow in order to enter their listings, and they want to operate in a trust and safety manner. For the buyers, they want to find goods at a good price, and they want also simplicity, good search, and they want also to operate on a trust and safety platform. And we have also another actor, let's say the law enforcement, the government, that implies some rules on what we can do on the platform. We can't buy and sell everything on the platform. And that's important for the moderation of our platform. So for the two first objectives, we can only satisfy the two objectives, having a well-organized and high-quality catalog and a powerful search. And for the second one, so the last objective occurs when a platform promotes by design good and compliant user behavior. And the platform is able to quickly detect and act on the wrong behaviors, taking actions on the catalog by rejecting forbidden items or taking actions on user to mitigate their influence on the platform. And the fact that it has to be quick, adaptable, and scalable implies use of AI technology to solve these problems. So we're going to look a little bit deeper in these two use cases, trust and safety, and especially the catalog moderation, and then the search and personalization on this platform. So first, let's go to trust and safety. And what does it mean? So we have to satisfy trust and safety in the marketplace platform, we have to get a lot of features in the product and process that must be in place to provide a secure and trustable transactions. So we have to provide a way to validate user identity. We also have to monitor user behavior to detect quickly scammers behavior. We have also to look at the chat and do some moderation on it in order to avoid harassment that it's particularly prominent in Turkey. We also have to take care of secure payment with our pay and shipment features. So there is a lot of things that can do with AI components. But last and least, I want to talk about the catalog moderation. That's the one we're going to go a little bit deeper in the next slides. So catalog moderation means that we want to avoid different things in our catalog. We want to avoid duplicate listings. We want to ensure some minimal quality of the image. And we want to also ensure that we avoid illegal content. So illegal content setting by the governments. There is some things that we can't do on our platform. We can't sell drugs, guns, or pornography or more heavy stuff. And there is also some forbidden content that Letgo said that we don't want to sell this type of things on our platform. That could be animals, underwear, or some perishable items like food. So these are the type of content that we have to moderate. And just think a detail on our type of content. Our content is highly multimodal. So we have some text and we have lots of image. And the moderation is quite done independently on these two type of sources. So we have some system looking at text and we have some automatic system looking at image. And just to get an idea of numbers and to understand why automatic system leverage on AI has to be used, just some numbers. So in our platform, we have 350K new listings per day. So if we want to review all the image for each listings, so let's say we have 5 images per listing on average, so it means that we almost have 1.7 million of images to review per day. So it's quite hard to do this task only by manual reviewing, and will also be costly. So we want to have a moderation workflow leverage an automatic procedure. So we have our user that's create and edit some listings, and these events goes to a dispatcher that launch the different detectors. We have the text detector, we have the image classifier, and then we have let's say brain of our automatic moderator that decides if this listings has to be automatically rejected, automatically approved, or flagged for being reviewed by manual moderations. So this is the automatic workflow or semi-automatic workflow that we implement at Letgo. And so in our case, we use Clarifai as the image classifier in our set of detectors. So for example, we have this type of image. So you can see that it's a little bit tricky, and you can also look at how users think in order to put that image into the platform. So this is obviously a gun, but it tries to put some image that try to confound the system. So this is a gun. We get that image. We send it to the Clarifai endpoint that we previously configured. The Clarifai give us some set of probability on the different concepts that we previously configured. In that case, hopefully the gun probability is higher than the animal one, especially the cats. And then we have some threshold decision logic that we apply. So we for each concept, we compare the probability to a threshold configured for that concept. So maybe the threshold for the gun will be different than the threshold for Unity. The threshold depends on the Lego policy requirements. Maybe in some concept, we want to be more sensitive than the others. And then overall, we have some an action to do, to flag or to approve or to discard. And we also have the best discard reasons. In that case, yeah, to be simple, we extract the best discard reason. We don't work with all the others concepts. And this is basically how we integrate with what Clarifai proposes as an image classifier. So on the metrics, we want to take care of the recall. So how many forbidden and illegal listings are flagged by automatic moderations. This directly is the compliance score catalog. How good is our catalog, or how noisy is our catalog? We want to take care of the precision. So how many flag listings are real forbidden listings? So this directly influence the type of stress we're going to put on manual moderation. If the system is less precise, we're going to put more emphasis, more work on the manual moderation. And also we take care of the volume, which is another way to look at precision. So volume sent to manual moderation. That's the three kind of metrics we're taking care in that project. So just a brief review on how the project worked. So we defined our concept, our taxonomy of forbidden and illegal items, and we configure it in the portal of Clarifai. We created data sets, we ingest it in the portal. I think we have 2 million images. We have like a steps of refinement of the data set with Clarifai support in trying to put more image in some classes that it was quite cool. And then we model it. So we use like a multi-class classification, so train with transfer learning on top of the general embedding classifier class that Clarifai proposed out of the box. Then we tune the threshold based on the recall precision performance according our policy, Letgo policy. And once we integrate everything, we continuously monitor the systems in order to be sure that we don't have drift in the different metrics. So that's all about how we frame the project. And some results that I can disclose. So the thresholds the Letgo threshold were tuned to optimize recall, not so much precision. So we estimate that the ground truths, we have 4 to 5% of new listing are really considered products to be rejected. And with a system tuned to recall, for the moment, we send only 40% of products to manual moderation. And the record depends on the category. So we plan to tune the model to improve recall in some category and also improve the overall precision. And with that, so it concludes the first use case, which was the catalog moderation, and on which we use the Clarifai technology. So now I'll let the floor to Julien that will explain you the second use case, which is more search and personalization.
Yes, thank you, Antoine. Hi, everyone. So as Antoine explained, now we have a clean catalog. All the items are completely legal. And the next problem we face is how do we connect the sellers and the buyers? And more specifically, how do we make sure that the buyers find what they are looking for in Letgo? So we have this huge catalog, and basically to kind of navigate through the catalog, there are 3 different ways. One is what we call the home feed, is what you see when you open the application. It's like the main feed, as in many different apps currently. The second one is using directly text search. So you enter words into the search bar, also very, very common entry point. And if you don't want to write text, you can also use the filters by categories or price or whatever to narrow down your search and find hopefully what you're looking for. So those are like the main entry points for the buyers. And now we will focus more specifically on the search part. And later we'll discuss a little bit as well about the home feed. But now let's focus on search. So what is search? Search is, I mean, everyone like you and me, we all use search every day in different applications. So it's a pretty well-known topic. And the flow is very simple, very intuitive. The buyer has an intent in mind and try to kind of map down this intent into words, which the user will enter into the search bar. No, very, very simple. We can guide a little bit the user using auto suggest, for example. Then we call a search engine and the magic happens, and it's very simple. We want to match all the listings that represent bikes. So very naive way is to look at the title or description, and if there is bike in the title, the word bike, I mean, then we are good. And there is good match here, which is bikes. And the, like, for example, those two cars, they don't mention bikes. They are not bikes. It's very intuitive. They are not good matches. So it looks like a very simple task, and also a very well-known topic, because, you know, Google is doing search for like decades. And so everything is already done in this world. But actually, searching for second-hand marketplaces is a bit different. It's a bit tricky, as you can, as we will see. For example, it's very different to web search, like Google, for example, because in Google, only the first page matters. Actually, you get top few first, like maybe 10 results, and that's all. You don't really need to care about the remaining. In our case, people always scroll down a lot. They explore a lot the results, because there might be several hundreds of very relevant results. So they have to really scroll down. So we have to return many good results, not only top 10. If you look at comparison, for example, with e-commerce like Amazon, in this case, in Amazon, all the products are super precisely defined. Like they have brands, they have categories, they have details about models, color, shapes, everything. But we don't have this. We have very noisy catalog, and all the listings are unique, because, you know, the same kind of iPhone sold by two different sellers will be different, because the condition is different, and you know, everything can be different. So we have a very specific use case of search, and the classical techniques might not work as easily as in other applications. All right, we also have a few limitations that prevent us from only using the text. For example, we are a local marketplace. It means that people can go out and meet in the streets to exchange the goods. So we have to take into account the distance between the buyer and the seller. It's not like, you know, if you can buy anything from anywhere. Another important thing is image quality. So Antoine mentioned it before, it's important for moderation, but also the quality of a listing tells a lot about the trust of the seller. And if you can expect really a good condition item, it's really important. The listing price, the price is set by the seller, but is it a good price? Is it like a good deal, or is it like a very conservative price? Can you guess from the price that the item is good or bad? So this is also very important for us. And of course, as you can see on the right-hand picture, the trust of the seller, like the reputation of the seller, is really key in this system. Again, going back to the trust and safety that Antoine mentioned. So we have to take all those signals into account. Now, let's take a step back. We only consider the text to keep it simple for now. And we will see that even like this, it's not easy. So here, this buyer is looking for a new bike, and he's typing mountain bike in his search box. And as a search engineers, basically what we want to do is, first we want to identify all the listings matching bikes, and then we want to decide in which order we want to show them. This is the classical approach to search. Okay, so let's do together a very simple intuitive example. So for my query is still mountain bike, and I want to identify out of those 6 listings, actually those are titles of the listings, and we want to identify which one would match with a very naive basic text match. So I just want to make sure that the words that I type are present in the title. So out of those, which one do you think are present in the search results. Okay, I give you 5 seconds so that you have time to look through the 6 alternatives. All right, maybe Antoine, can you click? All right, so I'm sure you guessed it. The first one actually is not matched because bicycle is different than bike in terms of words. They are very similar, we know it semantically, but they are different in terms of words. So this one, if we don't do anything, will not match. We have to take care about synonyms. It's a very, very important topic in search for us. The second one would probably match. Okay, those two words are not super close together, but it doesn't really matter. It can match. The third one would match, mounted back frame. Number 4 will not match automatically because it's written in a different language. It might be very, very important in some countries, maybe not in some other countries, but here it's very important. Number 5, Scout mountain bike will not match because there is a typo in mountain as well. So spelling is also very important. And the last one would match. So as you can see, there are many different reasons for explaining that we don't match relevant items. And this is very important for us. Antoine, can you go to the next, please? Yeah. Actually, out of the 3 that we would match, 2 might not be really relevant because they are not bikes. They are accessories or parts of bikes. So it's also another issue. So basically, to tackle this, one of the techniques that we can use, especially to tackle the synonym issue, is to build what we call embedding space for search queries. So we want to identify queries that are semantically very close together, like the one that I mentioned before. So there is a technique called search to vec that we can use for this, and it basically allows us to identify queries that are very, very similar semantically, and we can use them to improve the recall of the search. This is one of the techniques. There are all other techniques, of course, but this is one of the techniques that we use. Okay, we can go to the next slide. For the precision issue, basically, we cannot only rely on text as we have seen before. So what usually we do, we have to use other attributes. This is another example that you can look at. The query is red iPhone X. And if you look at those 3 possible results, only the first one has exactly the 3 words, red iPhone and X, but it's not an iPhone, it's a case. The second one has iPhone and many times, X many times, but it doesn't really look like a good result. And the third one, it's an iPhone X, it's red, but red is not present. So if you only look text, probably the last item will not be the top one, but the last one. So we have to add other attributes of the items to improve this ranking. For example, if you just look at the price, oh, $250 for the iPhone X, probably this one has a good price range and we want to boost those kind of items. So instead of doing this kind of reasoning manually, what we do is that we implement what we call learning to rank algorithms that will be trained on historical data from the users and will tune the relevance of the search and the precision of the search. Clearly, it's a quite advanced application. It's not easy to set up in production, but it's also super powerful. All right. Can you go to the next slide, please, Antoine?
Yeah.
All right. Now I will quickly go through another application. We will not go into details because for the sake of time. But in terms of home feed, here we don't have like search queries to tune what is a good feed or not. But personalization is really important in this space. So basically what we do, we can do different things at different levels, but the simplest thing that we can do is basically record user preferences, either based on explicit entries from the users or by implicit signals, like we can see the past searches of the users, past conversations, stuff like that, and we can guess what are the like preferred categories of the users, and we can use this to personalize the home feed. I went a little bit fast for sake of time. Antoine, if you can, yeah, I will explain the next one. It would be easier. Okay, so basically what we do is we keep a distribution of categories, meaning the categories that we think the user would prefer to see in the home feed. And also because we want kind of diversity into the home feed and allow the user to explore other categories, we will mix the personalized categories that we see on the right-hand side with kind of the default categories that the buyers would like to see. And by mixing those two things, we do kind of an explore-exploit paradigm, and the resulting distribution of categories is both personalized, but also generic enough to allow exploration for the users. So that's a pretty simple way to tune the home feed. Of course, we can do way more advanced stuff, like using similar learning to rank algorithms that we've seen in search, but in the main feed. But here it was just to explain a very simple, intuitive way to personalize the home feed. Maybe can you go to the next slide? All right. And another way as well to go a little bit deeper and more fine-grained into personalization, of course, is very popular, is to use recommender systems. And instead of just looking at category level, we can personalize at listing level itself. So it's a little bit more advanced, more complex to implement, but clearly very important for us because it allows us to really target correctly the users and simplify the experience for them. Yeah, so that's it. It was just kind of super high level overview of the kind of AI applications we see in secondhand marketplaces. There are other topics that of course we work on, but we just wanted to give a quick overview. So I hope that it helps. And if you have any question, please feel free to reach us and we can clarify a couple of points. Thank you very much for your attention.
Antoine, Julien, thank you so much for your presentation. I think it's a fascinating use case and clearly one where visual recognition becomes a very useful tool to be able to automate. So a big round of applause from our virtual audience, and we'll see everyone at the next session.